Hello, we are coming up to the second part of chemical kinetics. You need to have read the chapter carefully, and hopefully I will clarify any misunderstandings you may have about it. And I'm Ms. Bedrosian. All right, there are two types of rate laws. The first one is called the differential rate law. And this specifically describes how the concentration of the reactants affect the reaction rate. According to the law of mass action, the rate of a reaction depends only on the concentrations of the various substances. And remember, brackets means concentration. That, for example, it does not depend on the size of the container. This can be expressed as a direct proportionality in which the concentrations appear to be called the zero, first, or second power. This is also called the rate of reaction, or the order of the reaction. And we have some snowflakes. So now, of course, we're going to express this mathematically because this is chemistry, and everything is expressed mathematically. So when rate depends on concentration of reactants, we get a rate law. And here is the rate law. And remember, brackets means concentration. What's the unit for concentration? K is the rate constant, and this will change depending on the temperature of what's going on. Santa. The concentration of A is the concentration of reactant A. Lowercase m and lowercase n are called orders, and when you add them together, m plus n, this is called the reaction order. And all of these rates must be determined experimentally, meaning we cannot predict them in advance. They actually have to be done in the lab. So the unit for rate, if you haven't already figured it out, is molarity per second. Remember, a rate is always going to be per time of some sort. Something per time. So let's look at the different orders. We can have this rate equals K1, concentration of A. This is called the first order in the concentration of A, or reactant A. This one, can you predict what it is? It is first order in A and first order in B. I'm going to let you predict the next view. What is the order for this? And this one. And this last one. What are the orders? Here's the answers. This one is called the second order in A. Now this one is the second order in A and first order in B. This last one, can you get it? This is zero order. You may wonder, how do you get that? And here's the answer why. This doesn't depend on the concentration of reactants at all. It must only work by catalyst. Interesting. So when the concentration of A is doubled and the rate doubles, we call that a first order reaction. If the concentration of A is doubled and the rate doubles, but when B doubles, the rate quadruples, that would be second order. If I want to express this as rate, I would give it like this. First order in A, second order in B. This is end of part 2. I'll give you an example in part 3. So here it comes.